Moment of inertia.
So I'm not sure.
You are not sure. So moment of inertia I have discussed in the last class. So for different bodies, uh, different moment of inertia is there. For example, for like we have mass na, for different bodies, different mass. And when there is a linear motion, body is moving linearly like this. Suppose this is a pen, and pen is moving like this. So this is the linear motion. And suppose there can be another motion. This pen is rotating. Rotational motion is there. So two types of motion should be there. So when this pen is moving linearly, so here the mass, the role played by the mass force on this pen will be mass into acceleration. And when this body will rotate, and rotation is due to the torque, and torque is moment of inertia into angular acceleration. So same role will play the moment of inertia in the rotational motion as played by the mass in the linear motion. So in linear motion, mass is there. In rotational motion, moment of inertia will be there. So for different bodies, different moment of inertia is there. This is a rod. This is a rod. Okay. This is a rod, and this rod have the mass m and length l. So moment of inertia. Okay. Moment of inertia. Moment of inertia. So moment of inertia of the rod. One more thing for the moment of inertia is required axis. Axis. Okay. So this is the axis, and this axis is passing. This axis is like this. This is a rod. Suppose this is a rod, and there is an axis like this, perpendicular to the perpendicular to the rod. Okay. So the moment of inertia of this rod of length L and mass m about this axis is ml square divided by 12, and this axis is passing through the center of mass. So center of mass, what is center of mass? Center of mass is a point, okay, on the body. We assume there is a point on the body where whole mass is assumed to be concentrated. Wait. So moment of inertia of this rod about an axis passing through the center of mass. Okay, this is the axis passing through the center of mass and perpendicular to the rod is given by ml square divided by 12. ml square divided by 12. Okay, and if we want to find the moment of inertia of this rod about an axis which is passing through the end of the rod, which is passing through the end of the rod, and again the mass of the rod is m and L is the length of the rod. So the moment of inertia is represented by the I, capital I. So capital I is the symbol of moment of inertia. Okay, capital I. Like mass we represent with small m sometimes, or sometimes with capital M. So like moment of inertia is represented by I. ml square by 3. So this moment of inertia is ml square by 3 about this axis. So you can see here, if you will change the axis now, moment of inertia will change. Moment of inertia will change. Okay, and this rod we are assuming a linear rod, a one-dimensional body. After this we have ring. We have ring. Okay, so moment of inertia of ring having a mass m and radius r. So ring now, there is a ring. So the mass of the ring will be on the periphery of the ring. Okay, here there will be no mass. So we want to find the moment of inertia of this ring about an axis passing through the center of mass. So here will be the center of mass. Center of mass. Okay, passing through this axis will be mr square. Will be mass into radius square. Now another thing is a rectangle. This is a rectangle and rectangular lamina. Lamina means a body, two-dimensional body. Okay, so this have the mass m, length L, and breadth B. Okay, so two axes are there. First axis is this, and this axis is passing from the center of mass. So here is the center of mass, and here is another axis. This axis is also passing from the center of mass. So about this axis, the moment of inertia will be ml square by 12. So about this axis, so you can see here this axis is cutting this L. Okay, means perpendicular to the L. So you can write here ml square by 12. So and about this axis, the moment of inertia will be mb square by 12. After that, we have a disk. We have a disk. This disk has a mass m and radius r, and this is an axis which is passing through the center of mass of the disk. Okay, passing through the center of mass of the disk, and about this axis the moment of inertia will be mr square by 12. So this is a disk and this is a ring. Okay. So for ring here there is no mass, for disk here also there is a mass. After that we have annular ring. After annular ring means here there is a mass, here there is a mass, and here there is no mass. Means this ring has some thickness. Okay, this ring has some thickness. So this is the axis, and this axis is perpendicular to the plane of the ring and passing through the center of mass. The moment of and remember one thing, this is radius r1 and this radius is r2. Okay, this radius is r2. So the moment of inertia about this axis is m into r1 square plus r2 square divided by 2. Now cylinder. In case of cylinder, this is a cylinder and this cylinder is completely hollow cylinder. Completely hollow cylinder example, if you can take, you have seen the can of the Coca-Cola. That can be considered as, if you will remove the upper part of that, uh, then that will become, and lower part also. then that will become the completely hollow cylinder. So completely hollow cylinder having the mass m and the radius r. So this will be the radius r and mass of the cylinder is m. So about the axis of the cylinder, this is the axis of the cylinder. Okay, this is the axis. So about this axis of the cylinder, the moment of inertia will be mr square. And if the cylinder is completely solid, if the cylinder is completely solid, like you can say cell, uh, you have seen cell, na? So cell can be, we can say cell as the completely solid cylinder. So the moment of inertia of a completely solid cylinder about the axis of the cylinder is mr square divided by 2. Mr square divided by 2. Annular cylinder. Annular cylinder means a hollow cylinder having some thickness. eh? And this radius is r1. This here from here to here, this radius is r1, and this radius is r2. So the moment of inertia about the axis of the cylinder will be m into r1 square plus r2 square divided by 2. Now there is a triangle. If you have this triangle, triangular lamina. So lamina means this is a two-dimensional body. So this have the mass m, this triangle have the mass m and height h. So the moment of inertia about this axis, which is passing through the base. So you can write here about the axis xx. The moment of inertia will be m into h square divided by 6. M into h square divided by 6, triangular lamina. Now after that, we will discuss about the three-dimensional bodies. Three-dimensional bodies like sphere, cylinder is also the three-dimensional body. So sphere, hollow sphere, like you can say a cricket ball, a rubber cricket ball is a type of the hollow sphere. Okay. And sphere, for the sphere, if there is an axis, okay, this is an axis. Uh, this is an axis which is passing through the center of mass. Axis passing through center of mass. So there can be infinite number of axes that can pass through the center of mass. I can take one more axis that is passing through the center of mass. This axis is also passing through the center of mass. This axis is also passing through the center of mass.
So,
Hmm?
will the center of mass always be at the center of the body?
Not always. Center of the body means actually no, we have to define first what is the center of the body. This is not always true. There can be the difference in between the center of mass and the center of the body. Okay. So for the symmetrical bodies, no, like symmetrical bodies, uh, sphere, cylinder, rectangle, square. In this case, the center of mass and the center of gravity is okay. You are talking about the center of gravity. We will discuss that also. So in that case, center of mass and the center of gravity coincides in case of the symmetrical bodies. But if the body is not symmetrical, then it is not necessary that center of mass will coincide with the center of gravity. Okay. Center of gravity is a proper term. Okay.
Yes.
So suppose for example, this is a triangle. So for this triangle, if you are saying the center of mass will be at a distance of uh, here, which will be at a height of uh, 1 by 2 of h. Okay. Okay. It will be at a height, this height. But if you are saying that the geometrical center, okay, so in this case, the geometrical center will also be there because this is a symmetrical body. By the way, so here there can be infinite number of axes. Actually, the center of mass will be at a distance of h by 3. Okay, h by 3 from here. Now for this sphere, there can be many axes which is passing through the center of mass. Okay, so the moment of inertia will be 2 by 3 mr square. But the condition is the axis should pass through the center of mass. So here is the center of mass. Center of the sphere is in this case the center of mass. Or there is one more term we say geometrical center. Geometrical center is correct word for that. So in this case the geometrical center will coincide the center of mass in case of this sphere. In case of the cylinder also the geometrical center will coincide in this case also, 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 because these are the symmetrical objects. So in case of this symmetrical object, the center of geometry center coincides with the center of mass. Okay, so we are focusing on the moment of inertia right now. So moment of inertia will be 2 by 3 mr square. But if we have a hollow cylinder, if we have a this is a hollow cylinder, no? This is a hollow cylinder. Now for the solid cylinder, the moment of inertia about an axis passing through the center of mass will be 2 by 5 mr square. Hollow cylinder 2 by 3 mr square. Solid cylinder 2 by 5 mr square. In case of cone, if this cone is a hollow cone, like the birthday cap is, you can take the example. Birthday cap is like a hollow cone. So if you want to find the moment of inertia of the axis of the cone, about the axis of the cone, that will be m r square divided by 2. Solid cone is just ice cream. You can take the example of that ice cream if you will remove the upper part, upper hemisphere. So conical ice cream, na, we have seen. So solid cone, that is an example of solid. So moment of inertia will be about this axis, okay? About this axis will be 3 by 10 mr square. So these are some of the moment of inertia. And in the last classes, I have derived also how to calculate the moment of inertia. Okay, if you want to see that, so you should watch the recorded lecture, or you can take the help of any book also. So now we will solve one question on this. Okay, we will solve one question. This is a square. Okay, this is a square. We know that square have the all sides same length of length. Square have same sides. Same. What is the meaning of same side? Length of all the sides same. So this is a square, and this square has the side A. This is also A. This is A. This is also A. This is an axis. This is an axis, and this axis is passing through the center of mass. So here you can say geometrical center of this square coincide with the center of the mass, because this is a symmetrical object or a symmetrical figure. So this is the center of mass. Okay, center of mass. So you have to find the moment of inertia about this axis. This is the square lamina. Lamina means any two-dimensional object. Okay, so how we will find? We have seen this case. If you have a triangle, okay, and this triangle has this base, this base of the triangle, and about this base the moment of inertia is mass of the triangle, height of the triangle divided by 6, about the base. Okay, okay, no problem. Just a minute. Okay, so if I put the triangle like this, and now you can just see here, this square we can just divide in two triangles, triangle number 1 and triangle number 2. So no, it's fine. So triangle, this is the one triangle and this is the another triangle. Now if we want to find the moment of inertia about the base of the triangle, what will be the moment of inertia? Mass of the triangle, height square divided by 6. And it is given that side of the triangle is A. This is given. Okay, so this is first triangle, this is second triangle. So what we will do, we can find the moment of inertia of this triangle about this axis, and we can find the moment of inertia of this triangle about this axis, and we can add them. Okay, so moment of inertia of triangle 1, moment of inertia of triangle 1 plus moment of inertia of triangle 2. Okay, so moment of inertia of triangle 1 will be, and height, you have to remember what is the height here. So height is this, height, or you can say altitude. So this will be the height you have to take. This is the height you have to take. Can we find this height? We can find this height. This side is A. Okay, this side is A, and this is the diagonal of the triangle. This is the diagonal of the triangle. Or you can say this is also the diagonal of the triangle, and diagonal of the square. So diagonal of the square is A root 2. Okay, diagonal of the length of the diagonal of the square is A root 2, and this is half of the diagonal. So it will be A by root 2. It will be A by root 2. This much geometry you should know. Okay, so this height is A by root 2, and this height will also A by root 2. Okay, this height will also A by root 2, because this figure is symmetric figure. So this height is also A by root 2. So now moment of inertia 1 will be, now when you will, this is triangle 1 and this is triangle 2. So mass of this triangle will be m by 2, means half of the mass of the square, and here also you will take half of the mass of the square, because you have cut this square into two triangles, and mass will also equally divided. So you will write for triangle 1, what is the moment of inertia? I is equal to m h square by 6. So what is mass? Mass is m by 2, h square by 6. What is h? A by root 2 square. And 6 means you will multiply it 1 by 6. Plus, again you will write for the triangle second, you will write m by 2. Same thing you will write A by root 2 square multiplied by 1 by 6. So you can write it as 2 into m by 2, and you can write it as A by root 2 square multiplied by 1 by 6. So this 2 and 2 will get cancelled out. So you will have m, and this is A square by 2, A square by 2 multiplied by 1 by 6. So finally, what will be the answer? MA square divided by 12. The total moment of inertia about axis of this square lamina. Okay, do one thing. Take the screenshot of these moment of inertia. Okay. So again and again we will use some of these in the questions. So take the screenshots. Scroll down. Hello, Divyangi.
Yes. Good evening, sir.
Good evening. When you join. Hello. Hiva, is my voice okay?
Yes, sir.
Okay, so please, Hiva, for you, I'm saying just take the screenshots fast
Okay, done.
because done because we have already done this in the last class. I'm just telling you because this is very, very, very useful. Okay, 650. Okay, okay, no problem. It's fine. Okay. We have done only this thing. Scroll down.
Done, sir.
Okay. Okay. So separately write on the copy and try to learn these at least these moment of inertia. Scroll down.
Yes.
Okay. So after this, we will discuss. There are two theorems for calculating the moment of inertia: perpendicular axis theorem and parallel axis theorem. Two theorems are there. We will discuss that now. So now we will discuss the perpendicular axis theorem. Okay, so write down the this question also. This is a good question. Both of you, please write down. Done?
Done, sir.
Hiba completed?
Yes, sir.
So you will get this answer, okay? So in this question, now only thing you have to remember, this is a square lamina given. So if they are asking the moment of inertia about this axis, then we know ma square by 12. About this axis also we know, but they are asking an axis which is passing through the diagonal of this square. So through the diagonal of this square, we have to apply our mind. So we have divided this square into triangles, and we know this is the base of the triangle if we are considering two triangles. And about the base of the triangle, we know the moment of inertia, and accordingly we will add two moment of inertia. Means accordingly we will add the moment of inertia, and we will get this answer. So now we will discuss the perpendicular axis theorem. Perpendicular axis theorem means this is the theorem used to calculate the moment of inertia about any axis, about means about one axis if we know the moment of inertia about two other axes. But there are certain conditions to be followed. This perpendicular axis theorem is valid only for two-dimensional object. Two-dimensional object like you can say square, like you can say rhombus, like you can say disc, like you can say ring, like you can say rectangle. So these are some of the two-dimensional objects. We cannot apply on cylinder, on sphere, or any other three-dimensional object. Perpendicular axis theorem. Very simple. Perpendicular axis theorem. So applicable only for two-dimensional bodies. So Iz is equal to Ix plus Iy. I will explain you what is this. For example, suppose this is x-axis, this is y-axis, and this is z-axis. There is a body, and this is a planar body, two-dimensional body. Which body? Two-dimensional body. If the body is two-dimensional, then it will be planar also. So 2D body. Okay, two-dimensional body. This is a two-dimensional body, and this two-dimensional body is lying in XY plane. Lying in XY plane. Okay, no problem. It's fine. Okay. This body is lying in XY plane, and for the XY plane, Z axis will be the perpendicular for XY plane. If suppose this is a XY plane, this is XY plane. So perpendicular to this will be Z axis, like this also or like this also. This also. Okay, fine. Now, this is a rigid body. This is a rigid body. Okay, two-dimensional. You can say this is a rigid body. Now, focus. What I am doing. Suppose take very small mass of this body, because we know this body is made up of infinite, or you can say large number of small masses. I also made up of large number of small masses. Means everything is made up of small particles, masses, atoms. So we have taken just small mass of this body, and now we want the moment of inertia. We want the moment of inertia of this mass about x-axis. And here I have told you, if it is the condition like this, if there is a mass m, discrete mass m, and about any axis, if you want to find the moment of inertia, what you should know? You should know the perpendicular distance between the mass and the axis about which you want to find the moment of inertia. And the moment of inertia will be mr square. And r is the perpendicular distance. So now for this mass dm, we want to find the moment of inertia about the x-axis. So we want to find the perpendicular distance between this mass and the x-axis. So the perpendicular distance between this mass and the x-axis will be like this. Try to imagine. Okay, like this. And what is this distance? This distance will be y. If the coordinate of this mass dm is x and y. If this mass is lying on the xy plane, okay, if this mass is lying on the xy plane, then you can say the coordinate of this small mass is x comma y, x comma y. So this is the small mass. So from the x-axis the distance will be y, perpendicular distance will be y, and from the y-axis, from the y-axis there will be the perpendicular distance like this. Coordinate geometry 10 class. So this distance will be x. Okay, 1 minute. Okay, this is suppose y-axis, and this is suppose x-axis. Okay, and this is a point, and this is suppose a small mass. You can say dm. This small mass is lying on the xy plane. I am not talking about the z-axis now. This have the coordinate x comma y. So what will be this distance? The perpendicular distance from the x-axis will be y, and the perpendicular distance from the y-axis will be x. In 10th class, you have done this. So this is the thing I have used here. Now from the z-axis, what will be the distance? This will be the distance from the z-axis. This will be the distance. Can anyone tell me what will be this distance? Okay, you can just easily find. If this is x, na, so this will also be x. If this is x, so this is also be x. So now this becomes the right angle triangle here. This becomes the right angle triangle. Okay, so if you are considering this as a base and this as a perpendicular, so this will become the hypotenuse. And how you will find the hypotenuse? X under root of x square plus y square. So this distance, suppose this is O, and this point is A. Suppose this point is A, where the mass is placed. So what will be the distance OA? That is equal to under root of x square plus y square. Why I am just finding these distances? Wait, I want to find the moment of inertia. This for this small mass dm, moment of inertia of this small mass dm about the x-axis. What will be the moment of inertia? M into perpendicular distance square. What is mass? dm, and what is the perpendicular distance from the x-axis? That is y square. Now find the moment of inertia of this mass about the y-axis. So what is the perpendicular distance between the mass and the y-axis? dm into y-axis square. This will be the moment of inertia. Mass into this square. If you want to find the moment of inertia of this mass about z-axis, now what is the perpendicular distance between this mass and z-axis? That is dm into OA square. dm into OA square. What is OA square? X square plus y square. So it will become dm x square plus y square.
So that's perpendicular distance.
Yeah. All these distances are perpendicular distances. This also the perpendicular distance. This also the perpendicular distance. This also the perpendicular distance. Because moment of inertia for a discrete mass is mass into perpendicular distance from the axis about which you want to find the moment of inertia. So we have now moment of inertia about z-axis is equal to dm x square plus dm of y square. Now what is dm of x square? dm of x square is diy, and this will be dix. Okay, dm of y square is dix. Now this is this diz is the moment of inertia for the small mass. Small mass. Now when you will do the integration, na, diy plus diz. So when you will do the integration, so this d will be removed. You will get iz.
So it's
Mm-hmm.
dix, di
Hmm?
of x.
Hmm?
The last one.
This one. This one.
No, the one below.
This one. This is
Yeah.
we are doing the integration of whole equation. On both the side, we are doing the integration.
Yes, so it's di of z-axis equals di of y-axis plus di of x-axis, right?
Yes. D of iz means the small moment of inertia about the z-axis is equal to a small diy means the small moment of inertia. Small moment of inertia means moment of inertia of this mass, because this mass is the small mass. That is why I have written dx. I have told you we write na d of x. dx means very small distance dx. So whenever there is d, so that means the differential means very small. So okay, so when you will do the integration on both sides, you will get the final moment of inertia. You will get this as iz is equal to I y. Oh, this will be ix. Okay, this will be ix. So you can write this is your final answer. But this is valid when the body is two-dimensional and lying in one plane perpendicular to any other axis. So these are the condition here. X, Y, and Z are the axis should be perpendicular. Obviously, these axes should be perpendicular, not necessarily to pass from the center of mass. X and Y axis should be in the same plane of the body. You can say X and Y axis is in the plane of the body. Z axis should be perpendicular to the body. So this Z axis is perpendicular to the body. This is the body. So basically, this is a proof of the perpendicular axis theorem. Note down questions we will solve in the next class. Please take the screenshots because I am having the next class, so we do not have time. Both of you can take the screenshots.
Answer.
Okay. whenever I am doing some kind of derivation and all that means in derivation there are hidden concepts. There are hidden concepts in derivation. So don't think that derivation is not necessary. When we will do derivation, there are a lot of concepts in that derivation and that have to be understood. Okay, take the screenshot of this and try to, and after that, taking the screenshot, arrange the screenshot and write in your copy if you want the proper understanding of the perpendicular axis theorem.
So can you scroll up?
Scroll up, okay.
Okay, that's
Okay. Okay, don't miss the classes, okay, until and unless it is necessary to miss. Scroll down.
yes, sir.
Okay.